One, two, 1, 2, 3, 4.
Season's greeting to the great mind connected to this lecture. Today, we will be considering the trigonometric proof. This is an interesting part to deal with. I believe you will derive interest in it on the long run. Let's start by a well-labeled diagram with specified sides and angle theta. Also, we have the Pythagoras theorem and the trigonometric operation with respect to the sides. We call them SO, CA, TOA. SO is an acronym for sine opposite hypotenuse. CA is an acronym for cosine adjacent hypotenuse, while TOA is an acronym for tangent opposite adjacent. With the given right angle triangle, we have a well-defined expression for each. As for now, we only need the sine and the cosine only to prove a very useful identity, which we shall use throughout this lecture. Follow each step carefully. We want to prove the result of sine square theta plus cos square theta. Don't forget that we already have sine theta to be a over c and cos square theta as b over c. So, sin square theta becomes a over c square plus b over c square. When we convert it to a single fraction, it becomes a square plus b square over c square. Recall the Pythagoras theorem, a square plus b square equals c square. So, the numerator of our fraction becomes c square and the expression simplifies down to 1. And from here, a beautiful identity emerges. Sine square theta plus cos square theta equals 1. Highly welcome once again. Sine square theta plus cos square theta equals 1. Let this identity be named identity 1. I will use this identity to prove additional two identities which we shall always use for the proofs. For the second identity, divide through by cos square theta and modify the result. Tan square theta plus 1 equals sec square theta, which gives sec square theta minus tan square theta equals 1. This is another beautiful identity. Label it as identity 2. For the third identity, divide through by sine square theta and modify the result. This results in 1 plus cot square theta equals cosec square theta, which modifies to cosec square theta minus cot square theta equals 1. Label this as identity 3. There are the three identities that help in simplifying a question tower. Let us elegantly write out the resulting identities. The first, sine square theta plus cos square theta equals 1. The second, sec square theta minus tan square theta equals 1. The third, cosec square theta minus cot square theta equals 1. These are the identities. They are easy to memorize. In fact, you don't need to memorize the formulas. These are workings you can also do. You can make the proof just like I did. Now, let us look at some plausible tricks, tips and techniques that you can always use to know where to start your proof, how to start your proof, what to aim at in the proof, and things to know before the proof. Number 1, always start your proof from the loaded side. It is advisable that you always start your proof from the side that have big terms. It is easy to simplify expressions than to build them up. Number 2, always aim at reducing the three aforementioned identities. In the process of simplification, aim at factoring out any of the identities if possible. This will help in reducing the complexity of the proof. Number 3, ensure that you are good at factorizing and expanding polynomials. The knowledge of algebra is very important if you really want to do well in this proof. You should know the simple algebraic identities like the difference of two squares, cubes, and many other. Also, you should be able to expand some binomial function. It is very important. Number 4. Know how to express a trigonometric function in terms of another. After simplification, this will help you in modifying your result to suit the demand. Number 5. Always convert your function to the sine and the cosine functions. It is always easier to work with the sine and the cosine than working with cotangents and the likes. Number 6. Convert your fractional expression to a single fraction whenever you are working towards a single fraction. This is an idea you can visualize when modifying your simplified result to fit the required result. Now, let us consider some examples. Example 1. Prove that 1 minus tan square x over 1 plus tan square x is equal to 2 cos square x minus 1. We know that the loaded side is the left-hand side. So, we will start our proof from the left-hand side. Let's write out the expression on the left-hand side. From the second identity, we know that 1 plus tan square theta can be written in terms of sec square theta, so we substitute it and perform all necessary simplification. Along the line of solution, don't forget that sec square theta is 1 over cos square theta. Perform the conversion and simplify. Since the right-hand side is in the form of cosine, then modified the results we have. Cos square x into bracket 1 minus sine square x over cos square x, which expands to cos square x minus sine square x. This can be expressed in term of cosine only by using the first identity, since our goal is to arrive at the right-hand side of the equation, which is in term of cosine. And finally, we arrive at 2 cos square x minus 1, which happens to be the expression on the right-hand side. Thus, the proof is complete. Example number 2. We want to prove that 1 minus sine x over 1 plus sine x minus 1 plus sine x over 1 minus sine x is equal to minus 4 tan x over cos x. Of course, our proof will start from the left-hand side because it is loaded. All we just need to do is to simplify it to give the right-hand side. This is part of the previously discussed tips. Also, we notice that we are proving towards the right-hand side and the result there is in form of a single fraction. So, we need to convert the left-hand side to a single fraction in order to achieve our aim. This can be done by taking the LCM of both sides. Then we simplify and modify the result. We have 1 minus sin x times 1 minus sin x minus 1 plus sin x times 1 plus sin x over 1 minus sin x times 1 plus sin x. When arranged, this gives the difference of two squares in the numerator. Using the idea of algebra, it can be simplified as follows. When we expand the denominator, it gives 1 minus sine square x, which, by the first identity, is equal to cos square x. Let us substitute this into the equation, check the outcome and see how we can modify it to give the right-hand side. This can be arranged well to give -4 multiplied by sin x over cos x multiplied by 1 over cos x. This gives -4 times tan x over cos x, which is equal to the right-hand side. Hence, the proof is complete. The third example, we want to prove that 1 over 1 minus cos x plus 1 over 1 plus cos x is equal to 2 cos x square x. The proof shall start from the left-hand side. The reason is clear to you now. Since the result on the right-hand side is a single function, let us convert the left-hand side into a single fraction by taking the LCM. Now, let us expand and simplify the numerator and the denominator. Since 1 minus cos square x is equal to sin square x, perform the substitute. And also, 1 over sin square x is equal to cos x square x. Thus, our result becomes 2 cos x square x, which is equivalent to the right-hand side. Thus proved. Example 4. We want to prove that tan x plus cot x is equal to sec x cosec x. This is interesting. By insight, I will choose to start the proof from the left hand side, so that conversion to single fraction will be the only task there for me. You may decide to start the proof from the right hand side, it is your choice. All road leads to Rome. Just ensure that your simplification and modification is error-free. Let's convert the tangent and the cotangent to the functions of sine and cosine. To modify it as a single fraction, take the LCM of both, then apply the fraction. Conversion procedure. This gives sin x plus cos x over sin x cos x. This is equivalent to sin square x plus cos square x over sin x cos x. The numerator by the first identity is equal to 1. So we have 1 over sin x multiplied by 1 over cos x. This gives sec x multiplied by cosec x, which is equal to the left-hand side. This completes the proof. Example 5. We want to prove that 1 plus sin x over cos x is equal to cos x over 1 minus sin x. This is a very nice question. You can start this proof from either the left-hand side or the right-hand side. You will undergo same stress in either ways. I will like to start my proof from the right-hand side. Cos x over 1 minus sin x. To simplify the denominator, let us rationalize it. This can be achieved by multiplying both numerator and the denominator of the fraction by 1 plus sin x. By expanding the denominator, we arrive at a stage where the first identity will be implemented. The denominator gives 1 minus sin square x, which we write as cos square x, by convention. We see that one of the cosine functions cancel out, leaving cos x in the denominator. Let's collect our result. We have 1 plus sin x over cos x. This is equal to the left-hand side, hence, the proof is complete. Example 6. We want to show that sine x raised to the power of 6 minus cos x raised to the power of 6 is equal to 1 minus 2 cos square x multiplied by 1 minus sine square x cos square x. To prove this, let us start from the left-hand side, since all we need to do is to factorize and eliminate some terms to arrive at the expression on the right-hand side. Sine x raised to the power of 6 minus cos x raised to the power of 6 is equal to sine x raised to the power of 2 times 3 minus cos x raised to the power of 2 times 3. Just in the same way we will factorize the difference between two cubes. In such way, we do this also. A cube minus b cube is equal to a minus b multiplied by a square plus a b plus b square. The same method applies for our expression, just that a is equal to sine square x and b is equal to cos square x. So, we have sin square x minus cos square x multiplied by sine x raised to the power of 4 plus sine square x cos square x plus cos x raised to the power of 4. Now, we compare the expressions and see how we can make them look alike. Setting sine square x as 1 minus cos square x will make the leading brackets equal. This is very similar to the left-hand side expression, except that we have sine x raised to the power of 4 plus cos x raised to the power of 4, which is not on the right-hand side. We can simplify this by our algebraic expression again. A raised to the power of 4 plus b raised to the power of 4 can be written as a square plus b square square minus 2a square b square. Now, use sine x and cos x instead of a and b. We get the following result. Which we then substitute into our expression. Carefully study the substitution process here. This gives 1 minus 2 cos square x multiplied by 1 minus 2 sine square x cos square x plus sine square x cos square x. This simplifies down to 1 minus 2 cos square x multiplied by 1 minus sine square x cos square x. This is perfectly what is on the right-hand side of the equation. Hence, the proof is complete. Example 7. We want to prove that 1 plus sine x over 1 minus sine x is equal to 1 over cos x plus tan x square. Let's start the proof from the right-hand side. Write tan x as sine x over cos x. Then take the LCM of the expression in the bracket. After that, distribute the power, 2. By the first identity, the denominator becomes 1 minus sine square x. This can be written as a difference of two squares. By separating the numerator and the denominator into products, we see that 1 plus sine x cancels out, then we are left with 1 plus sine x over 1 minus sine x. This is the expression on the left-hand side, thus the proof is complete. We want to prove that sine x plus sine y over cos x plus cos y plus cos x minus cos y over sine x minus sine y is equal to 0. To prove this, let's start by converting the side to a single fraction. The following emerges. Now, expand the numerator. We obtain sin square x minus sin square y plus cos square x minus cos square y over sin x plus sin y multiplied by cos x plus cos y. The resulting expression can be grouped into pairs. Sin square x plus cos square x minus sin square y plus cos square y over sin x plus sin y multiplied by cos x plus cos y. We see that each of the pair forms the first identity. So, we obtain a result of 1 minus 1 in the numerator, which is equal to 0. Since the numerator is equal to 0, the whole expression, this becomes 0. And the proof is complete. Example 9. Show that sin x plus cos y square plus cos x plus sin y multiplied by cos x minus sin y over sin x plus cos y is equal to 2 cos y. By starting our proof from the left-hand side, let us firstly expand cos x plus sin y multiplied by cos x minus sin y. This little part gives cos square x minus sin square y. In order to obtain the difference of two squares in which the denominator will be a factor, let us convert cos square x to 1 minus sin square x and sin square y to 1 minus cos square y. One cancels out, and we are left with the difference of two squares. From here, we take th difference between the squares conveniently, and we simplify. Follow the steps keenly. Sin x plus cos y cancels out from the expression. Now, by collecting the result, we have sin x plus cos y minus sin x. Hence, the result becomes 2 cos y, and the proof is complete. Example 10, the last example in this lecture. If 1 plus cos square y over 1 plus 2 sin square y is equal to sin square x. Show that sin square y is equal to 1 plus cos square x over 1 plus 2 sin square x. By starting from the first equation, we only need to undergo two steps. The first is to make sin square x the subject of relation. The second is to modify your result to get the desired result. Let's start the process. Turn cos square y to 1 minus sin square y, then let's work towards sin square y. Follow the simplification keenly. Now, we have this result, sin square y equals 2 minus sin square x over 2 sin square x plus 1. Now, let's modify our expression to arrive at the desired result. We just need to convert sin square x to 1 minus cos square x in the numerator. Our result then becomes 1 plus cos square x over 1 plus 2 sine square x. And the proof is complete. Clap if you want to clap.
I'm gonna stand up for what I stand for. Fight till finish and win the war. I'm gonna keep on